Welcome back. Today we will be talking about finding solutions for the trig using the unit circle and sum and difference formulas. So let's get started. Example 1. So if we have 2 sine x is equal to 1, I can rewrite it as sine x is equal to 1/2. Now on the unit circle, x will be pi 6 or 5 pi 6. Now, because you need, that's why I said you need to have a good understanding of the unit circle. Now, because the period for the sine function is 2 pi and they have not given any domain restriction, we can say pi 6 plus 2 k pi plus 5 pi 6 and 5 pi 6 and plus 2 k pi. So whenever there is no restriction, you need to write the period as well. So you need to understand that there can be infinitely many, let me rewrite it again. So infinitely many solutions. Any angle that forms the coterminal with these two angles, that means pi 6 and 5 pi 6 for this particular problem, will also be a solution for this particular problem. Now, also, always remember that always write the exact value and avoid any approximation. That means any decimal approximations. Okay, keeping that thing in mind, let's take a few more examples. So we have sine x minus radical 2 is equal to negative sine x. So I can combine the like terms. So it will be 2 sine x is equal to positive radical 2. And then I can say sine x is nothing but radical 2 over 2. Now on the unit circle, radical 2 over 2 will happen at pi fourths and 3 pi fourths, wherever sine is positive. That means quadrant 1 and quadrant 2. But remember, you need to write the period as well. So the period of the sine is 2k pi or 2n pi. So we will include that one as well. Another example, we have 4 sine squared x minus 3 is equal to 0. So the same thing again. I can clean it up and say sine x is nothing but plus minus square root of radical 3 over 4, which is radical 3 over 2. Now radical 3 over 2 plus and minus, that means in the positive and the negative quadrant both, that will be pi thirds plus 2n pi on the unit circle, and also 2 pi thirds, 2n pi, 4 pi thirds plus 2n pi, and 5 pi thirds plus 2n pi. So we are taking into consideration where the sign is positive and where the sign is negative. So quickly, let's do another example. Sine squared x is equal to 2 sine x. I can combine and factor out sine x. That will be sine x minus 2 is equal to 0. So I need to figure out where sine x is 0. So sine x will be 0 on the x-axis, right? So that will be 0 plus 2n pi, or at 0. So 2n pi. Let's continue and do one more example. So the rhythm of this chapter is the same. You need to find the angles where the particular trig value should be. So in this problem, they are asking for find all the solutions. And the given is 2 sine squared x minus sine x minus 1 is equal to 0. So now it looks like a quadratic, right? So I can factor the same way as the quadratic. If it makes sense, then you can assign let u is equal to sine x and make it more quadratic. So if I factor it out, this is what I will get. And one by one, I can put them equal to 0. So this will give you sine x is equal to negative 1/2. So negative 1/2 will happen at 7 pi 6 and 11 pi 6. And this will give you sine x is equal to 1, which will happen at pi over 2. So these type of problems can be solved with a simple understanding of quadratic. In another example, we have 3 secant squared x minus 2 tangent squared x minus 4 is equal to 0. Now, to turn into something more feasible, I can use the property of secant squared x, which is tangent squared x plus 1. Now, everything is in terms of tangent. And if you clean it up, you will get 3 tangent squared x plus 3 minus 2 tangent squared x minus 4 is equal to 0. Combine the like terms and you will get tangent squared x minus 1 is equal to 0. That is nothing but tangent squared x is equal to 1. And if I take the radical both sides, it will be plus minus radical of 1, which is nothing but 1. Tangent is 1 at pi fourths and 3 pi fourths, right? So remember, the period for the tangent is n pi, so I need to include the period as well, because we are considering pi fourths as a positive and negative for 3 pi fourths. Now, another example, we have cos x plus 1 is equal to sin x. Now, I cannot handle it right this way. So let's use another strategy, that is square both sides, because our Pythagorean theorem for the trig is in the square. Sin squared x plus cos squared x is equal to 1, right? So let's square both sides. And if you square both sides on the left hand side, you need to use the property of a plus b whole squared, which is cos squared x plus 2 cos x plus 1 is equal to sin squared x. And let's rewrite everything in terms of cos. So sin squared x can be written as 1 minus cos squared x. Now it is time to combine the like terms, which will give you 2 cos squared x plus 2 cos x is equal to 1. Factor out 2 and cos x. So 2 cos x in the brackets, we will get cos x plus 1 is equal to 0. One by one, we will put them equal to 0 and we will try to figure out the angles. So cos x is 0 at pi half and 3 pi half. Cos x is negative 1 at pi. Now we got these three angles. Let's do checking part. If you remember in algebra 1, you used to get the solution and then find the extraneous solutions, right? The solutions that doesn't fit the equation. So to check, we will use the original equation. So original equation was cos x plus 1 is equal to sin x. So one by one, we will plug all these angles and see if both sides matches. So cos pi half is just a 0. Sin pi half is 1. It matches. We will do the same thing with x is equal to 3 pi half, and let's see what will happen. So 3 pi half will give you a 0, but that will give you a negative 1. It doesn't match. That is my extraneous solution. Now lastly, we have x is equal to pi, and if I plug it back, I will get negative 1 plus 1 is equal to 0, which is nothing but a 0. So sometimes some questions will ask you to check your answers. Let's take one more example. So as you can see, all the examples are a little different. So 2 cos 3t minus 1 is equal to 0. So I'm getting cos 3t is equal to 1 half. On the unit circle, we cannot have 3t is equal to 1 half, because that will give you t is equal to 1/4. We don't have 1/4 on the unit circle. So what we will do, let's assign u. Let u is equal to 3t. Now we can safely say cos u is equal to 1 half. Now on the unit circle, what angle will give you 1 half? There will be two angles that will give you 1 half. So the first one is pi thirds. So if I substitute the value of u, that's 3t back, I will get t. Divide both sides by 3, so that is pi ninths plus 2/3 k pi. And the another angle, where cos will be 1 half, we will do the same thing, is 5 pi thirds. So after getting that angle, let's substitute the value of u back and divide both sides by 3 so that we can get the value of t. So t will be 5/9 pi plus 2/3 k pi. It should be 2/3. I forgot to write 3. right? So it should be 5/9 pi plus 2/3 k pi. Okay, let's take one more example. This time, let's use inverse. So we have secant squared x minus 2 tangent x is equal to 4. Again, rewrite secant squared x as tangent squared x plus 1. And then is minus 2 tangent x. And this can be written as a quadratic. Tangent squared x minus 2 tangent x minus 3 is equal to 0. Let's factor it the same way we factored the quadratic. So in the factored form, we will get tangent x minus 3 and tangent x plus 1. If you put them equal to 0 one by one, we will get tangent x is equal to 3, or x is equal to tangent inverse of 3. And the other will be tangent inverse of -1. Now, tangent inverse of -1 will be -5/4, right? So, remember the period. Period is only n pi. No, it is not 2 pi, it is n pi. Just pi. Period for tangent is pi. Cot and tangent, they have the period of pi. So let me rewrite it. So x will be arc tangent 3 plus k pi, and x is equal to -5/4 plus k pi. Okay, after this, we will do sum and difference formulas for sine, cosine, and tangent. There is a pattern in the sum and the difference formula for sine and cosine, and as well as for the tangent. So if I say sine A plus B, the same thing will go with minus. If it is minus, we will just change the sign into minus. So sine goes along with cos. So if I have sine A, we will have cos B plus sine B cos A. If it is minus, then the sign will change. But cos, as I say, it is a little bit moody. Cos tries to remain isolated from sine. So cos A, cos B, and the sign will also change. If it is positive, then it will become negative. If we are talking about cos A minus B, then the symbol between them will become positive. On the other hand, tangent A plus B, the numerator will follow tangent A plus tangent B, but in the denominator, the sign changes and we multiply tangent A times tangent B. So tangent A minus B, the same pattern, tangent A minus tangent B, but in the denominator, instead of minus, it will become positive. Now, why we do all of these sum and difference formulas. So these sum and difference formulas will help us to get the exact value of the trig functions, including sum or difference of special angles, right? Let's understand them and use them in some questions. So in the first example, we have cos of pi 12ths. Now on the unit circle, pi 12ths, we can figure it out pi 12ths, but we don't commonly use pi 12ths. So the idea is if I can split the fraction with the basis that is there on the unit circle. So what are the bases on the unit circle? We have pi half, pi thirds, pi fourths, pi sixth. So 2, 3, 4, and 6. So if I make the denominator of pi 12 in terms of 2, 3, 4, 6, then I can write the cos function as sum or difference. So pi 12 can be split into pi thirds minus pi fourths. So pi thirds will work as angle A and pi fourths will work as the angle B. And this becomes the example of cos A minus B. And remember, cos goes all along. So it goes separately, cos A, cos B. Now because it is minus, it becomes plus. So plus sine A, sine B. So cos has its own rhythm. Sine goes along with cos, but cos has its own rhythm. So what is cos of pi thirds? Then cos of pi fourths plus sine of pi thirds times sine of pi fourths. So on the unit circle, that's why unit circle is very, very important. And you don't have to memorize it. It's just the first quadrant that you need to understand. So these will be the values. And if we clean it up, simplify it, we will get radical 2 plus radical 6 divided by 4. So same thing will happen. Same way you can solve if the angle is in degrees. For example, cos 75 degrees, cos 6, maybe 95 degrees or 135 degrees, how you will solve it. So try one question. Find the exact value of sine 75 degrees. The same thing, split 75 degrees in terms of the common angles on the unit circle. 30, 45, 60, 90, and so on. Let's take one more example. Now in this particular problem, they are asking for the exact value of sine A plus B, and some information is given. They said that sine A is 4/5 provided angle A is greater than 0 but less than pi half. Further, they said that cos B is negative 12/13 provided angle B is greater than pi half but less than pi. Now, we know SOHCAHTOA, right? Let's apply this on the quadrant. So for the sine function, because it is between 0 to pi 2, it is quadrant 1, and for cos, it will be in quadrant 2. So let's create two triangles in quadrant 1 and quadrant 2 respectively. So for the first one, we have 4/5. So sine, remember, it is opposite over hypotenuse. So we have opposite, we have hypotenuse, we don't have the adjacent. And the same thing, cos is adjacent over hypotenuse. So we have adjacent and hypotenuse, we don't know the opposite. So we can use the Pythagorean theorem and we will get the opposite as 5 in quadrant 2. And for quadrant 1, it is a Pythagorean triple of 3, 4, and 5. Now we have all the sides, we can calculate, we can figure it out what will be cos A and what will be sine B, because they want sine A plus B. So sine B will be 5/13 and cos A will be 3/5. Now let's apply the formula for sine A plus B. Remember, sine goes along with cos. So sine A cos B plus sine B cos A. And let's plug all the values in. So these will be the values. If you multiply and add the fraction, it will be negative 33/65. Let's take one more example. Write algebraic expression. This time let's take tangent. Oh, never mind. Let's take sine. Sine times arctangent 1 plus arc cos x. Now, they are nothing but they are asking for sine A plus B. In this case, A is working as arctangent 1 and B is working as arc cos x. So let me try to create two triangles. One is done. Let's create one more. Uh-oh, it is upside down. You know what? I didn't like it because it's very close to the equation. So let's redo it. Here we go. So we have two triangles ready, right? Now, when we are talking about arctangent 1, let's say, let A is equal to arctangent 1 or tangent inverse 1. So that implies tangent A is 1. And what is tangent? Opposite over adjacent. So that means we have opposite and adjacent as 1 and 1. So this is 45, 45, 90. So that will give you hypotenuse as radical 2. Along the same line, let b is equal to cos inverse x. So cos b is equal to x, and cos is nothing but adjacent over hypotenuse. So if adjacent is x, hypotenuse is 1, can I figure out what is the opposite side? Let's use the Pythagorean theorem. 1 squared is equal to x squared plus missing side squared. So the missing side will be 1 minus x squared inside the radical. Now we have all the sides ready. So let's use the sum formula for sine. Sine A plus B. Remember, sine goes along with cos. Sine A cos B plus sine B cos A. So we got sine A. So let's find the values. So sine A will be 1 over radical 2 because opposite over hypotenuse, and cos A will be 1 over radical 2 again. Sine B, opposite over hypotenuse, so radical 1 minus x squared, and cos B will be just x. Let's put them in the equation. Now here, I am not changing the denominator in which is a radical 2, because we will do it once we get the answer. We can rationalize in one go. So if we clean this and make a common fraction, we will get something like this. Now we have a radical 2 in the denominator. We need to rationalize it. So radical 2 times x plus radical of 1 minus x squared, and everything divided by 2. And we can leave our happy-chappy answer right here. Okay, sorry about that. Let's take one more example. This time, they are asking you to simplify. Let's take tangent. So this is the example for tangent A minus B. What is the rhythm? In the numerator, it will be tangent A minus tangent B, but in the denominator, negative will become positive and they are multiplied. So tangent A minus tangent B divided by 1 plus tangent A times tangent B. So tangent theta minus tangent pi fourths divided by 1 plus tangent theta times tangent pi fourths. What is tangent pi fourths? Is 1. So tangent theta minus 1 divided by 1 plus tangent theta. And that is your lovely answer. Okay, let's take one more. Perhaps the last one. Now they're asking you to find all solutions, and then they have given us one problem. And this problem involves using the sum and difference twice. And we have the restrictions here. So we have sine A plus B format, and then we have sine A minus B format. You know the rhythm. Sine goes along with cos. Sine A cos B plus sine B cos A. We will do the same thing again, this time with minus sine A cos B minus sine B cos A, and everything equal to 1. Now, on the unit circle, we know the value of cos pi half, sine pi half, cos 3 pi half, and sine 3 pi half. Let's plug those values in. That will be sine x times 0 plus cos x times 1, sine x times 0 again, minus sine negative 1 times cos x. So anything times 0 is 0, so we will be left with 2 cos x is equal to 1. And we can say cos x is nothing but 1/2. Now, a cos x will be a 1/2 on what angles? At pi thirds and 5 pi thirds. This is my happy chappy answer. After this, I want you to try and verify this particular equation using the concept of sum and difference formula. So they want cos x plus h minus cos x over h equal to something like this. So you have to apply the concept of cos A plus B. Give it a try, and I will see you in the next video. Bye.